Good morning, everyone. I am Dr.Partha, Professor, Electrical Engineering Department, Haldia Institute of Technology. Today, we will see some more features regarding microprocessor, mainly 8085 microprocessor. In our previous classes, we discussed regarding regarding different uh, terms, mainly some definitions, different architecture of 8085 microprocessor. So today it is a part 3 of introduction to microprocessor. In this part, mainly we will discuss regarding uh, some instructions which require for assembly language programming. Now, what is assembly language programming? First, let me discuss. During the invent of microprocessor, it can only understand binary codes, binary language. That means 0 and 1. Total binary coding. But it is very difficult for a user to write a program in terms of 0 and 1, because it consumes spaces, and also it is very difficult to find any mistake if happened, because all are zeros and ones. Now after this 0 and 1, after this 0 and 1, that binary structure, a new code came that is called hex code. Generally 4 binary digits, they form one hexadecimal number, 4 binary digits. So the total effort reduces by 1/4, 25%. But still, it is difficult to write a program in terms of hexadecimal coding. Then one language came that is quite similar to English words. It is called assembly language. When we just study assembly language, we can see that the words, they resemble with common English words. So, microprocessor programming is assembly language programming. Different microprocessor means different types of microprocessor has its own assembly language programming. That is 8085 has its own assembly language programming. 8086 has its own assembly language programming. and for that purpose the assembler needed for different types of microprocessor, they are different. So first we will here study some very basic instructions which we use in 8085 microprocessor. Different instructions are there for programming. The instructions are classified into 1 byte instruction, 2 bytes instruction, and 3 bytes instructions. Now what happens? It is a very good programmer who can write a program with less space. In 8085 microprocessor, one problem may be written into different ways. That is, if we change the algorithm and flowchart for a same problem, the programs will be different. So, the programmer should write a program in such a way so that it consumes minimum space. And also, in 8085 microprocessor, one instruction takes some certain amount of time for its execution. The programmer should also keep an eye on that issue that the program should take minimum time and minimum space during its execution. This is a very simple instruction I am discussing here. A very, very simple instruction. MOV RD, RS, description, copy data from RS to RD. MOV means actually move instruction, but it is a copy paste instruction. In our previous lectures, we have seen that in 8085 microprocessor, different registers are there. 8-bit registers, they are called, just for a recall, 8-bit registers, most registers user accessible, they are 8-bit register, it is a 8-bit microprocessor. Its general purpose registers are B, C, D, E, H, L. These 6 general purpose registers are there, which are of 8 bits. B, C, D, E, H, L. And accumulator, which is also termed as register A, it is a very, or it is the most vital register in 8085. So MOV RT, RS means RS is the source register and RD is the destination register. That is, consider register B contains a data 07H. Why It is H. H means hex. Register B contains 07H. I want to copy that data into register C. So what I will write? MOV C, B. Here B is the source register. Source register means where data is there. And the data, where the data I should copy, it is called destination register. So if I write MOV C, B, that means B is the source register, C is the destination register. If I write MOV B, C, then C is the source register, B is the destination register. That is, the original data, if original data is there in A, I want to copy that data in D. So what I write? MOV D, A. That is, the source register, it is written later than the destination register. So it is a very basic instruction of 8085 microprocessor. All the MOV instructions, they are 1 byte instruction. That is MOV A, B, MOV B, A, MOV C, D, any MOV instruction. All these instructions, they are 1 byte instruction. Here opcode is MOV, operand is RT, RS, and description copy data from RS to RD, source to destination. So the examples: opcode MOV B, C, copy data from register C to register B. So if register C contains 4AH, remember it is a hexadecimal number system. So 0 to 9, then A, B, C, D, E, F. So MOV B, C, copy data from register C to register B. MOV A, D, copy data from register D to register A. MOV D, A, copy data from register A to register D. For first instruction, MOV C, B, C, C is the source register, B is the destination register. If C contains 4AH, then after this instruction, the contents of C remains same 4AH, but contents of B will be 4AH. MOV A, D, if D contains 00H, then after that instruction, the contents of register D will be same 00H, content of register A will also be 00H. MOV D, A, if content of A is 1AH, then after this instruction, contents of A will be 1AH, contents of D will also be 1AH. So like this. So MOV instructions, they are all of same pattern, and this is a very basic instruction. This instruction is a 1 byte instruction. Next, MVI RT 8-bit data, M, 8-bit data. Move immediate 8-bit data to register memory. Now, what is this? RD means destination register and then 8-bit data. Look at this example, then I will again show the previous type. MVI A5AH. 5AH is the 8-bit data. Where I should copy that 8-bit data? I should copy that 8-bit data into register A or accumulator. So load data 5AH into register, that is accumulator A. So MVI stands for move immediate. That is, that data will be directly copied to register A after this instruction. MVI B 7CH, move data 7CH into register B. That is, it is a directly I am loading a particular hexadecimal number into a particular register. The register may be a general purpose register, the register may be an accumulator. So here MVI instruction RT, data, move immediate. Achha, M is called memory. Memory register, it is a dynamic register. When I discuss regarding general purpose registers, I discuss these registers BC, DE, HL. BC is a register pair, DE is a register pair, HL is also a register pair. The memory address which is pointed out by HL register pair only, they are called, that register is called memory or capital M. So MVI instruction, it is a 2-byte instruction. It is we can directly load a data into a register or into a particular memory location whose address is pointed out by HL register pair only. Here MOV B, C, as I discussed, C is the source register destination. MOV B, C is the source register, B is the destination register, and MOV A, B. So these are 1-byte instruction. So and MVI is a 2-byte instruction. MVI A 5AH, MVI B 7CH, these are all 2-byte instruction. Now we will write a very small program. Addition of two 8-bit numbers. For addition of two 8-bit numbers, one instruction is there, that is called add, ADD. Add B, add C, like this. One number should be in accumulator or register A, and second number should be in register B, C, D, anything, but one number should be in accumulator. So what is add B? Add B means add the content of accumulator with the content of register B and store the final result into accumulator. That is, new content of accumulator will be the old content of accumulator plus the content of register B. So that is add B. One number should be in accumulator register A, second number should be in register B. So MVI A01H, MVI B02H, add B, halt. Achha, halt HLT, halt is a 1-byte instruction which indicates end of a program. Add B, it is also a 1-byte instruction. So MVI A01, I want to add two numbers, 0, very simple program. I want to add two number 01H and 02H. I want to add these two number and I want to store the final result into accumulator. So what I will do, I will write MVI A 01H, then MVI B 02H, then add B will add 01H and 02H and store the result into accumulator, and then HLT halt means end of program. So how much space it takes that program? MVI A01H. MVI instruction is a 2 byte instruction. MVI B02H, it is also a 2 byte instruction. So 2 plus 2, 4. Add B, it is a 1 byte instruction, and halt, it is also a 1 byte instruction. So 2 plus 2 plus 1 plus 1. That means total that addition program, a very simple addition program, addition of two 8-bit numbers, it takes 6 bytes of space. After addition, the contents of accumulator will be, the content of accumulator is equal to content of accumulator plus content of register B. That is, accumulator content is variable. The new content of accumulator will be the old content of accumulator plus the content of register B. Now, similar way, we can see subtraction. Subtraction between two 8-bit numbers. Here also, we have to take one number into accumulator and other number into any general purpose register. The register may be B, C, D, E, H, L, any register. So, MVI A04H, that 04H, that number will be loaded to register A. MVI B01H, that 01H number will be loaded to register B. Then sub B. Sub B means new content of register A is equal to old content of register A minus content of register B. And then halt. That is, new content of register A is equal to old content of register A minus content of register B is equal to, that means in this case, 4 minus 1 is equal to 3. Here also, this is a very small program of addition, subtraction. This program also takes 6 bytes. Now, after addition instruction, after subtraction instruction, the contents of accumulator changes and the contents of flag register will change and reflect the result of operation. Then one instruction I am discussing, LDA 16-bit address, load accumulator direct. The contents of the memory location specified by a 16-bit address in the operand are copied into the accumulator. The contents of the sources are not altered. This is a 3-byte instruction. So if the content of 9001, that memory location is suppose 5AH, then after this instruction, the content of accumulator will be 5AH. LDAX B register, it is an indirect instruction. LDA instruction, it is a 3-byte instruction. LDAX B oblique D. B C register pair will point to a particular memory location, or D register pair will point to a particular memory location. After that instruction, that content will be copied to accumulator. It is a 1 byte instruction. And then thank you for your